Welcome to our tutorial on using Chainlink for decentralized oracles. In this video, we're diving into what decentralized oracles are and how Chainlink can help you connect smart contracts to real-world data. By the end of this video, you will have a comprehensive understanding of Chainlink and how to implement it in your projects. First, let's clarify what decentralized oracles are. Oracles serve as bridges between blockchain and the outside world, enabling blockchains to interact with external data sources securely and reliably. Decentralized oracles like Chainlink enhance security by eliminating a single point of failure, thus mitigating risks associated with centralized data sources. Next, let's look at the limitations of centralized oracles. Centralized oracles can be vulnerable to various types of attacks, including data manipulation and outages. This lack of security can lead to inaccurate data being fed into smart contracts, ultimately jeopardizing the integrity of blockchain applications. Now, let's pivot to Chainlink. Chainlink employs a decentralized network of oracles to provide a trustworthy way to feed real-world data to smart contracts. This is achieved through consensus mechanisms among multiple oracle nodes, ensuring verified data. Before we start coding, let's prepare our environment. You need to install Node.js if you haven't already. Head over to Node.js's official website and download the installer. Make sure to install the LTS version for better stability. After installing Node.js, let's initialize our project. Open your terminal and create a new directory. Navigate into it and run npm init y to create a package.json file. This file will manage our project's dependencies. Now that our project is set up, let's install the Chainlink libraries we need. We will be using web3.js to interact with the Ethereum blockchain and Chainlink contracts. Run the following command in your terminal. Now let's dive into coding. We will create a basic smart contract that will request data from a Chainlink oracle. First, we need to set up a Solidity file. Create a new file called oraclecontract.sol. Now, open oraclecontract.sol in your code editor. We will start by specifying our version pragma and importing the Chainlink contracts. This is essential for implementing Chainlink. Next, we will create our contract variables. We'll need to set the link token address and the Oracle contract address. These addresses will point to the specific oracle we plan to use for our requests. Let's add a constructor function to our contract. This constructor will initialize our link token and oracle address when we deploy the contract. Next, we will add the function that interacts with the Chainlink oracle to request data. We'll call this function requestData. This function will accept parameters like the job ID and the request fee. The fulfill function will be how we receive the data returned from the oracle. It's critical to define this function to handle the oracle response. Define it right after your requestData function. Now that we have our basic contract set up, let's deploy it to the Ethereum network. For this tutorial, we'll deploy it on the RinkBy network. You'll need to get some test link tokens and some ETH for the gas fees. You can get some ETH from a faucet and link tokens from a Chainlink faucet. Once the deployment is successful, note down the deployed contract address. Now, we need to interact with this deployed contract from our JavaScript code. Create a new file, interact.js, in your project directory. In interact.js, let's set up our Web3 instance and connect to the deployed contract. This ensures we can call the functions defined in our smart contract. You need to replace your _Infura ID with your actual Infura project ID and your _contract address with your deployed contract's address. Next, we will create a function to call our requestData function. Now you can run this JavaScript file using Node.js. Ensure you replace the job ID and fee parameters as per the Oracle job configuration available on Chainlink's documentation. Let's quickly recap what we have learned today. We set up a basic decentralized oracle using Chainlink, wrote a smart contract that can request external data, and interacted with our contract through JavaScript. By integrating Chainlink into your projects, you can significantly enhance their capabilities and make them more robust and efficient. The decentralized nature of Chainlink ensures that your smart contracts are fed accurate and trustworthy data. For more advanced apps, consider checking Chainlink's other features, such as additional data sources, verifiable randomness, and on-chain data aggregation. Finally, don't forget to like and subscribe to stay updated with our latest tutorials. If you have any questions, drop them in the comments below, and I'd be happy to help. Thanks for watching, and until next time, happy coding!